Okay, welcome. This is part one of our lecture video series from Wednesday, March 8th, where we are going to compare side by side our two different bonding models, the Lewis bonding model here in yellow and valence bond theory here in blue. And the way that I'm going to compare these for you is by using a Venn diagram. So we're going to show the differences between these two models and their similarities in this overlap space here. And hopefully that will give you an idea of how Lewis and valence bond theory are different and used in different ways and give different information about how things are bonded in a chemical compound. So let's start with our Lewis model of bonding. So in our Lewis model, we know that electrons are treated as purely particles, which we represent using dots. And in covalent compounds, electrons are shared between atoms. So specifically, this sharing of electrons is what we call a covalent bond, where two shared electrons is equal to a single bond drawn as a line in a Lewis structure. If our atoms have four shared electrons between them, then that is a double covalent bond. And if our atoms have six shared electrons between them, then this is called a triple covalent bond. And overall, the information that a Lewis dot structure gives is the number of and types of bonds, like how many double bonds, where are they? This gives us information about potential resonance, structures of our compounds, which explains some things like stability. And it also tells us the location of lone pairs of electrons, or generally non-bonding electrons. And that's the beauty of Lewis, right? We get this nice two-dimensional portrait of what's going on in the bonding scheme of a particular compound. Okay, let's compare this to our valence bond theory, at least what we know of valence bond theory so far. So valence bond theory is our first bonding model that we've seen that recognizes the fact that electrons are quantum mechanical particles, meaning electrons reside in some orbital that is designated by some energy level. So in valence bond theory, electrons are quantum mechanical particles that are found in orbitals. In other words, we can describe any valence electrons in an atom via a valence electron configuration, right? Where our electron configuration gives us information about energy level, orbital type, spin, things like that. And while Lewis said that a shared electron pair is what a bond is, Valence bond theory adds a little bit more detail, which says that a chemical bond is a region of orbital overlap that exists between two or more atoms. So a bond, according to valence bond theory, is a region of orbital overlap. And there are specifics here. It's a region of orbital overlap such that half-filled orbitals on atoms combine or overlap to form a spin pair electron in that overlap region. We have seen so far that when we have some kind of orbital overlap that is head-on, so like if I've got orbital from atom A over here, and then orbital from atom B over here, because these are combining in this head-on manner, the region that contains our overlap and thus our spin paired electrons, one from atom A and one from atom B, this forms what we call a sigma, or using the letter, sigma bond, which is probably closer to what you and I would call a single bond in the Lewis model. We are not quite at a phase in our discussion of valence bond theory where we understand where double and triple bonds come from. We're going to get to that. But for now, we know that by definition, anytime we have orbital overlap with spin paired electrons inside that orbital overlap as a result of there being half full orbitals that were the ones that overlapped in the first place, that creates a bond between our two atoms known as a sigma bond, as long as that orbital overlap is this head-on kind of direct collision. So these seem like pretty different models, right? What on earth would make them similar? Like, how would they have any kind of agreement? Like, is there any kind of commonality that exists between our Lewis model of bonding and valence bond theory? So what these two models agree on is that two shared electrons, or two electrons that are now in an occupied or shared overlap space, are what constitute a single bond. So these both have a bond being defined as some kind of pairing of valence electrons between atoms. It's just in the Lewis model, that pairing was kind of taken for granted. Like we just said, oh yes, these things share, and we drew a straight line to show that sharing. And valence bond theory seeks to explain what the nature of that sharing is and where it comes from, namely orbital overlap. So now that we kind of understand the differences of Lewis and valence bond theory, and also kind of now resulting limitations of Lewis theory, let's continue our conversation about valence bond theory, where we really kind of remind ourselves about some of the key tenets of valence bond theory, beyond just the fact that a bond is defined as a region of orbital overlap where half-full atomic orbitals combine to form a spin pair. Like this right here, this is like the overall summation of valence bond theory. But as noted on Monday, there are a couple of weird things that happen, namely this phenomenon called hybridization, which is what I want to talk about in our next kind of wrap-up discussion of valence bond theory. So in video 2, We're going to go over those key points. So we're going to kind of review this general definition as seen below. And then from there, we're going to go into more detail about our different types of hybridization, sp3 and sp2 today, where we're going to make a distinction between kind of like complexities in sp2 hybridization toward the end of the lecture.